Hey everyone, I'm Evgeny and welcome to the AI for Developers series, your basic course from concepts to code. So, why another video on AI? You might be thinking, is this just another tutorial on how to write prompts for ChatGPT? Well, no, that's not what we are doing here. These videos are for developers, people like you and me, who actually want to build things. I'm going to help you take your first practical steps into the AI world. So, let's start. Now we'll cover a bit of theory, because, yeah, you need to understand what UI is and how it works. But no worries, we'll keep it light, just the basics, so we can jump into what really matters. Alright, let's dive in. Okay, let's start with something familiar, ChatGPT. I'm sure you've all heard of it by now and you probably what it does. I can type in my questions or prompts and this AI will respond with logical, human-like answers. For example, I can ask it to explain a concept or even help me write some code, like generate a JavaScript code snippet that reverses a given string. Pretty cool, right? It definitely gives off that wow factor the first time you see it. But here's the thing, what's really going on under the hood? How does this AI actually work? Let's take a quick look inside and break down the magic. So, here we have our AI chat agent. Let's call it the generative AI agent. We can send it some input and it will give us a response. In generative AI, this input is called a prompt. And if you have tried using ChatGPT, you have probably come across lots of tips and tricks on how to craft a perfect prompt. There are even templates that help guide you, so AI generates exactly what you need. And the response we get from the AI, that's called the completion. So far so simple, right? But how does this Gen API agent actually generate those responses? This is where things get more interesting. You have probably heard the term LLM or large language model. That's the core of our AI, the engine driving how it processes the prompt and generates the completion. The LLM is what powers the Gen API agent's ability to understand and create human-like responses. But it's not just about the model. There is also some pre-processing that happens before the prompt even reaches the large language model. The input is cleaned up and formatted in a way that the model can understand. So it's here, right? And once the model generates a response, there is a bit of post-processing as well to make sure the output is ready for us to read or use. So, to recap, we send a prompt, the LLM inside our Gen API agent processes it, and we get a completion, all with a bit of magic behind the scenes to make it work smoothly. And that's the basic idea of how this whole thing works under the hood. Not too bad, right? Alright, so far so good. We know that the user types a prompt, it goes into the Gen API agent, and the LLM generates a response. But what exactly is a large language model? So, now we are not going to dive too deep into the technical weeds, at least not yet. For now, let's simplify things a bit. Think of an LLM as a massive neural network. It's been trained on huge amounts of text, words, sentences, patterns, and the relationships between them. It works kind of like how our brains process language. When you heard a word, it triggers association in your mind, but those associations don't come just from the word itself, right? A lot of other factors influence how you interpret it. For example, imagine someone says something to you. The way you interpreted that depends on who said it, how they said it, the context they're in, and even factors like whether it's cold outside or you're hanging out with friends. LLMs work in a similar way. At their core, they are massive networks that can recognize patterns in language, and they use something called transformers to process and tag this information. Now, I won't go too far into the technical details, but that's actually why GPT in ChatGPT stands for Generative Pre-trained Transformers. Those transformers help the LLM adjust the meaning of words based on the context. Let's give me an example. Let's say we have this sentence. When Mary and John went to the store, John gave a drink too. The transformers can tag this sentence with context. For example, Mary is recognized as a person and John is also a person, and store is a place where goods are sold, and so on. So when the model sees this input, it uses these tags to figure out what's likely to be next or what's likely to come next. That's the key task of an LLM, predicting the next word in a sequence, given the context of what came before. And to do that, it uses a huge database of words and all their possible relationships. Words in this database are represented as vectors. Think of them as mathematical points in space. The model analyzes the relationships between these words, vectors, to predict which word should come next. For example, in our sentence, the model might predict that Mary is the most likely recipient of the drink given the context. Of course, this is a very simplified view of how an LLM works. In reality, this process is much more complex and involves layers upon layers of computation. But for now, this should give you a basic idea of what's happening behind the scenes. All you really need to remember is that the LLM takes a prompt, analyzes the context, and tries to predict what comes next in the sequence. Alright, so now you should have a pretty good understanding of how AI works when it receives a prompt. It processes the prompt and predicts what the next word might be. But what happens after that? It's pretty simple. The prompt gets updated with that new word, and this updated sequence is fed back into the LLM as a new prompt. And this process repeats over and over. Each new word gets added to the sequence, and the AI keeps predicting the next word based on the updated context. Here's how it works in practice. The AI predicts the next word and keeps going until it reaches the end of the sequence. And that's when the AI knows it's done, when it hits the special marker known as the end of sequence token. So, to sum it up, the LLM keeps working through the sequence one word at a time until it's predicted the entire response and knows the conversation is complete. It's a bit like a continuous loop of guessing the next word based on what's already generated until the AI knows it's time to stop. So, we have been talking about how LLMs work with words, but it's time to reveal that. Well, that's not exactly true. In reality, AI doesn't work with words per se. It works with something called tokens. Now, what are tokens? Simply put, tokens are logical units of information. Sometimes a token is an entire word, but sometimes it's only part of a word. Take this word, for example, unbelievably. It's actually made up of several tokens, and these are multiple concepts that merged into one word over the time. The goal of an LLM is to work with the meaning of words, not their exact form. That's why every word, even punctuation, gets broken down into tokens. Now, let me show you this in action. As you can see, this text is broken down into tokens. Each word and even punctuation is treated as one or more tokens. So, with this new understanding, we can now say that the LLM doesn't try to predict the next word. It's actually predicting the next possible token. And this is why sometimes when AI generates a response, it might pause in the middle of a word. It's still thinking about how to finish the token. And here's another technical detail. Machines are better at processing numbers than characters or tokens directly. So before doing any heavy lifting, the AI converts each token into numerical code. See, this long piece of text gets broken into tokens, but what the AI actually works with are the IDs of these tokens, not the words or tokens themselves. All right, so that's how tokens work, but there is one more important concept to know, the context window. AI can't handle inputs of arbitrary size. For example, you can't input an entire book and ask the AI to write a sequel. There are limits. The context window is the total size of your input combined with the output the AI generates. And different LLMs have different context window sizes. For example, the context window might be large enough to handle a couple of paragraphs, but not an entire chapter. And once you hit that limit, the AI can't process anymore. So, when you are working with AI, keep in mind that you can only fit a certain number of tokens, whether they are part of your input or the AI's response into that window. Anything beyond that just won't fit. All right, that's a lot of information, but I hope it all makes sense. Tokens are the building blocks of AI responses, and the context window is the boundary that defines how much the AI can handle at once. All right, we have covered a lot of ground today, so let's take a moment to recap what we have learned. First, we started by understanding how AI generates responses. We sent a prompt and the AI processed it using a large language model and generates what we call completion. Essentially, it's like the AI is predicting the next word, well, actually talking, in a sentence over and over until the task is complete. Then we learned that AI doesn't really work with full words. Instead, it breaks everything down into smaller chunks called tokens. Sometimes a token is a whole word, but sometimes it's just a part of a word or even punctuation. We also touched on the fact that AI doesn't process these tokens as words directly. Instead, each token gets converted into a numerical ID before the AI starts working its magic. And this is how machines can work with languages. They are really just working with numbers. And finally, we discussed context windows. This is the limit on how much text the AI can process at once. It combines your input with its response to stay within that limit. Once it reaches the maximum capacity, it can't handle any more information. Those are big takeaways. We have talked about how AI takes your input, breaks it into tokens, works with those tokens as numbers, and then builds a response, one token at a time, all while staying within the limits of its context window. I hope this helped demystify how AI like ChatGPT actually works under the hood. As developers, understanding these concepts is key to harnessing the power of AI in real-world applications. Okay, thanks for sticking with me today. Be sure to subscribe if you haven't yet, and stay tuned for more deep dives into AI and programming. I'll see you in the next episode. Bye.